My name is Joe Lyding. I'm a professor of electrical and computer engineering at the University of Illinois. I do scan probe microscopy, which is a way of looking at surfaces at atomic resolution. The problem with the scan probe microscopes consists of two things. One is the actual microscope body, which does the scanning, but there's also a probe that is the actual interface between the microscope and the surface that you want to study. And making those probes sharp is not an easy task, atomically sharp. One day I was running an experiment in the lab and everything was going well except the probe wasn't sharp, so that I wasn't getting the data I wanted. And it was very frustrating. And then it occurred to me that there is a sort of a natural way to sharpen these probes that people hadn't tried. And what the method involves is you take a sharp metal probe and you blast it with ions, the energetic ions, and when the ions hit the probe, they actually blast off a process called sputtering. They knock atoms off the tip. And what the basis of the idea was is that if we put an electric charge on that tip, when the ions come in, they actually get deflected. And what that does is it causes the sputtering to occur more around the sharpest part of the tip. Instead of blunting the tip, it makes it sharper. And the sharpness, as the sharpness increases, the electric field associated with the sharpness also increases, which causes more of that deflection to occur, so it actually enhances the effect. And what you end up with is very extremely sharp tips, almost atomically sharp, without having to do any type of manual control. Any type of microscope, its resolution is limited by sort of the physical mechanism of the imaging. In one of these scan probe microscopes, since it's a sharp tip interacting with the surface, the sharpness of that tip determines the area of interaction. And if you have an atomically sharp tip, then you can essentially get atomic resolution imaging of surfaces, because the process is just based on physical laws, and you don't need an operator to say stop now. It always gives the same result. That's the kind of consistency that that people are going to need when they buy these probes. And what we have now is a process that guarantees uniformity and sharpness. This process is very reproducible. In fact, because of that, we're actually beginning to commercialize it ourselves.